There are two sets of tables in this code book. One set is yours, the other set is the utilities. Your tables are 30C. The utility tables are 40C. Don't ever get them mixed up. I'm going to take you and show you why your tables are 30C. Turn to 310.15B1. 310.15B1. Ambient temperature adjustment. Notably in the table header, it says ambient temperature correction factor based on 30C, 86 degrees. In observation, down the left is Celsius, down the right is Fahrenheit, and the three columns, 60, 75, and 90, are the grades of your insulation. So whatever insulation you are using, that's where you belong. So if you use a UF or a TW, you're in the 60C column. You use a THW, you're in the 75. If you use a THHN, you would be in the 90C column. If you don't know where your insulations belong, all you got to do is turn over to 310.16, and they are listed in their appropriate column. Go down to Fahrenheit until you get to 86 degrees and look at the number in the three columns and tell me what it is. 1. 1 or 100. You just found the happy place for electricity. As long as you install between 78 and 86 degrees, your systems will run at 100% efficiency. Why would we build you a book for anything less than the skills you possess? This in observation proves what I said about the heat factor. When you see a 1 in front of the number, that's an improvement. Electrons like to be a little cold. When we go in the opposite direction and you don't see a 1 in front of the number, that is now losing efficiency. And you can, in observation, realize that it takes very little heat to begin to change the performance of your systems. But your tables for installation are all 30C. Because as long as we build our systems and maintain a conditioned space of 78 to 86, it matches your skill sets and you're building a 100% efficient system. What we have no control over, and I do include it in exam prep because I do not think it's fair for you to leave this room and not have a full understanding. The book is already designed to put you in a position to build efficient systems, and your skill sets are unmatched. But what we don't have control over is that we fail, just like we did with not telling you the conductors have 2 jobs, is to tell you we have 3 grades of equipment, and that's what we don't have control over. And without that knowledge, you shop based on money, not on performance. We have 3 grades of equipment, just like you have any different grades of vehicles. And so it begins with 30C at the top of the pyramid. That enclosure, that panel board, that load center will maintain heat control through that bonding jumper system, or design and layout of interior components will stay between that 78 and 86 degrees and keep shedding that heat. From there we go to 40. Now we're up to 104. Now that thing's going to hold heat and operate between 40C. So when you look at the table in observation and you go to that 40C, you're now in a heat range of 96 to 104 degrees before that thing actually starts. And if you look at the 75C column, which is service equipment, you now find out that has 12% resistance. When you go up to our lowest grade, it is 50. And you find out that its operating temperature is 114 to 122. And now you find out it's only 75% efficient and has a 25% resistance. The only reason it works in your favor in those residential load centers is because you don't have that much loading. You've only got about a 35 to 40 amps per leg. But you would never want to make that mistake in industry or commercial. So now you know why your tables are 30C. So now I'll show you 40C tables. The one underneath, that's your utility table for temperature adjustment. Their standard is 40C. So how you ended up with the utility tables is when the utilities went to the utility commissions and said, we no longer want to put in secondaries. We want the electricians to put in secondaries. And we also want the electricians to buy the service equipment. We don't want to give it to them anymore. We did not want you chasing the utilities for that information. So therefore we went to them, got that information, and put it in your code book. So there is your utility temperature adjustment. Their standard is 104, 40C. Now I'll show you utility tables. So 31016 is your table as noted in note 1, 30C. 31017, that is your table as noted in note 1, 30C. But now 31018 is the utilities version of your 31016. And as you can see, it is a 40C table as referenced in the note under the table. And then 31019, single insulated and free air. 20 on messenger. And 21, if this doesn't give it away, nothing will. Bare and in the air. If that's not a utility term, I don't know what is. So notably, what you find out about the utility is that they typically don't like copper in the air because it stretches. So they buy aluminum because they can buy it with a steel core and it won't stretch. So their favorite insulation is Z-rated. So their tables actually work from right to left and not left to right, because the only time you're going to see them employ copper is underground. So notably, their table works from right to left, unlike yours that work from left to right, because we're just the opposite. We like copper. And so now you know you have your utility tables. Thank you for watching our video. This was a sample of our paid training. If you're looking for someone to provide you with exam prep, or you're just looking for continuing education hours, go over to jcrproductions.com. We would love to see you in class and provide you with all the things you need for a professional electrical education. We're looking forward to seeing you in class.